Hello students, welcome back to my channel. Let us continue learning number systems. In today's session, we will be learning about conversion from other number system to decimal. In the previous session, we had learned how to convert any given decimal number into binary and octal as well as hexadecimal. Today we will be doing the vice versa. That is, if I have a binary number, how am I going to convert it into decimal, from octal to decimal as well as hexadecimal to decimal. So let us quickly go through. So the very first what we will be learning is how do I convert any given binary number into a decimal number. So the first example, let us take, I have the number 1101. Okay, this is the binary number. How do I convert this into a decimal number? Now, remember here, every time you want to convert from any number system to decimal number system, we will be multiplying each individual digit with the powers of the base. All right. So in this case, since it is a binary, the base is 2. Hence, we will multiply all individual digit with the base powers of 2. So I will multiply. So the powers will start from 0 from the rightmost, and it will go towards the left in this order. So 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. All right. So let us write. So 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. Okay, now let us expand this. 1 into 2 to the power 3 is nothing but 8. So 1 into 8 plus 1 into 4 plus 0 into 2 plus 1 into 2 to the power 0 is nothing but 1. All right. So 1 into 8 is 8 plus 1 into 4 is 4 plus 0 into 2 is 0 plus 1. Hence, I will be getting 8 plus 4 plus 1 is nothing but 13. Hence, the number 1101, which is in the binary, is nothing but 13 in decimal. This is how we convert. Okay, I hope this is clear. Now, let us take the same example which we had done in the previous session, that is 65 and 122, which we had converted. Now, let us cross-verify and see if we have done it correctly. So, when we had converted 65 into binary, we got the number 1, 0, 0, 0, 0, 0, and 1 to the base 2. Okay, you can go back and check the previous video and we can see. Now, I want you to pause the video and try it yourself. Try and convert this into a binary. Okay. Now, the powers which I'll start is 0, 1, 2, 3, 4, 5, and 6, which is nothing but I'll expand and write 2 to the power 6 plus 0 into 2 to the power 5 plus 0 into 2 to the power 4 plus 0 into 2 to the power 3 plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. Okay. Now, as you can see, this is all 0. I can just ignore it. I'm going to write only the numbers which is valid. So 1 into 2 to the power 6 is nothing but 64 plus 1 into 2 to the power 0 is nothing but 1, which will be 64 plus 1. Hence, we will be getting 65, which is in decimal. So as you can see, this is matching. Okay, now let us try doing 122. 122, when we converted into binary, we got the number. Again, this also we have solved in the previous session. So I want you to go back and check. So 122, we got 111010. This is what the binary conversion we got. All right. So 0, 1, 2, 3, 4, 5, 6. This numbering you need not do every time. Once you are aware of how to write that, you can easily straight away go ahead and write. As of now, since I'm making you understand it, I'm going to be writing it. All right. So 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. All right. Now, if we have to write, I'm not going to expand it like before. So as you can Understand 1 into 2 to the power 6 is nothing but 1 into 64, which is nothing but 64 plus 32 plus 16 plus 8 plus 0 plus 2 plus 0. This is what we will get. So once you add all this, we will end up getting 122. Okay. So every time if you're doing a conversion, you can cross verify by converting it back. So this is how we will do the binary to decimal conversion. Next, let us see how can we do the conversion from octal. So like I told you before, any number if you're converting from a different number system to the decimal number system, you have to multiply that particular number with the base of that number itself. So here we have octal. Octal is nothing but the base 8. So let us take one example, 257. This is an octal. If I have to convert it into decimal, then how will I write? Once again, 0, 1, 2 is going to the power of 8. So 2 into 8 to the power 2 plus 5 into 8 to the power 1 plus 7 into 8 to the power 0. Okay. Now this is nothing but 2 into 64 plus 5 into 8 plus 7 into 1. All right. So this, when I expand further, multiply and write, I will get 128 plus 40 plus 7, which is nothing but 175 to the base 10. So 257 to the base 8 is the octal number. When we convert it into decimal, we will get 175. Now we can convert this back to the octal. That how do you convert 175 divided by 8? Try doing this and check whether you are getting this number itself. That is how you will do the cross verification. All right. Let us take the same example once again. 65, which we had converted, decimal, which was in decimal, we had converted into octal and we got 101 to the power 8. Let us see if it is, let us cross verify and see. Okay, so 1 into 8 to the power 2 plus 0 into 8 to the power 1 plus 1 into 8 to the power 0, which is nothing but 64 plus 0 plus 1. Of course, it is 65 to the base 10. Okay. Another conversion which we had done in the previous session is 122, which was in the decimal. We had converted into octal and we got 172 to the base 8. So let us convert 1 into 8 to the power 2 plus 7 into 8 to the power 1 plus 2 into 8 to the power 0, which is nothing but 64 plus 56, 7 8s are 56 plus 2. Once again, this is nothing but 122. This is the decimal number. All right. This is how we convert from octal to the decimal. The last one for today is hexadecimal conversion. So since it is in hexadecimal, now we will be multiplying it with the base of 16. Let us take a number 3A5. 3A5. Now, as you can see, this is a base 16. That is, it is a hexadecimal number. So if I have to multiply, I will multiply 3 into 16 to the power 2 plus A into 16 to the power 1 plus 5 into 16 to the power 0, which is nothing but 3 into, now 16 square is nothing but 256 plus, now A here is nothing but 10. So 10 into 16 is nothing but 160. I will write it in this way, 10 into 16 plus 5 into 1. Now further simplifying, we will get 768 plus 160 plus 5. If you add all this, you will get 933 to the base 10. So when I convert 3A5 to the base 16, which is the hexadecimal number, with the decimal, I will get 933. Now try converting this back to the hexadecimal by dividing it by 16 and check if you're getting 3A5 as an answer. This is how we will cross verify. All right. Now, once again, let us take the previous session's example, which is 65 to the base 10. We had converted into hexadecimal and got 41 to the base 16. Let us convert 4 into 16 to the power 1 plus 1 into 16 to the power 0, which is nothing but 4 16s. 4 16s, we will get 64 plus 1, 60 to the power 1 is 1, 1 1s, we will get 1, which is nothing but 65. All right. One more number which we had tried is 122 to the base 10. When we had converted, we had got 7a as a hexadecimal number. Converting this back to the decimal, we will get 7 into 16 to the power 1 plus a into 16 to the power 0, which we can write it as 7 into 16 is nothing but 112 plus 10 into 6 to the power 1 is 1, which is nothing but 112 plus 10 is 122. All right. So this is how we will do the conversion. So to quickly summarize, if you want to convert from decimal to any other number, then you will divide those particular number from the base of those number. That is, if it is binary, then you will divide by 2. If it is hexadecimal, you will divide it by 16. And if it's an octal, then you will divide it by 8. But if at all you want to convert from other number systems, okay, other number systems to decimal, then what you will do is multiply with the power of respective. That is, in the case of binary, you will multiply it with 2 to the power. If it is octal, you will multiply with 8 to the power. And if it is hexa, you will multiply it with 16. That is, each number, whichever is given, when you multiply, the resultant will be a decimal number. All right. So that's all in today's session, students. Thank you for watching. If there is any confusions, please let me know in the comment section. I will try to solve it. Thank you for watching. Keep learning.